friends. Today's my lecture is on factors affecting force of contraction. So there are various factors that affect the contractility of skeletal muscle, and these are first of all strength of stimulus, number of stimulus, temperature and load. So effect of strength of stimulus. When the muscle is stimulated by the stimuli with different strength, the force of the contraction also differs. So first of all, the types of strength of stimulus. There are 5 types, and we have already discussed about all these types of strength of stimulus. We just revise. Subminimal or subliminal stimulus. It is less than minimal strength and does not produce any response in the muscle if applied once. Minimal stimulus, threshold stimulus or liminal stimulus. It is the least strength of the stimulus at which the minimum force of contraction is produced. Then submaximal stimulus. It is more than minimal and less than maximal strength of stimulus. It produces more force of contraction than minimal stimulus. Then maximal stimulus. It produces almost the maximum force of contraction. Then supramaximal stimulus. It produces the maximum force of contraction, and beyond this the force of contraction cannot be increased. Then second factor is effect of number of stimulus. Contractility of the muscle varies depending upon the number of stimuli. If the single stimulus is applied, muscle contract once, and that is a simple muscle twitch, and graphical recording that is known as simple muscle curve. 2 or more than or multiple stimuli that produces two different effects. So effect of two successive stimuli. When the two stimuli are applied successively to a muscle, 3 different effects are noticed depending upon the interval between the two stimuli. First is beneficial effect, then wave summation, then summation effect. So first of all, what is the beneficial effect? So this is the graph of beneficial effect. So when the two successive stimuli are applied to the muscle in such a way that the second stimulus that falls after the relaxation period of the first curve, then two separate curves are obtained and the force of the second contraction is greater than the greater than that of the first curve. And this is known as beneficial effect. So in this figure you can see this is the point of first stimulus and this is the point of second stimulus. So this stimulus we give after the relaxation of period of first curve. Then what is the result? There are two separate curves are obtained and the force of the contraction of the second curve that is greater than that of the first one, and that is known as beneficial effect. Then why there is a beneficial effect? So during the first contraction the temperature increases and it decreases the viscosity of muscle. So as the temperature increases the viscosity decreases. So the force of the second contraction is more. The second stimulus that gets benefited by the changes produced in the muscle due to the first stimulus, and that is release of the more calcium ion from the sarcoplasmic reticulum, then increase in the temperature of the muscle during the first contraction, then decrease in the internal viscosity and resistance of muscles, and resistance of the muscles are due to mainly series elastic component being already stretched, then decrease in the inertia of the recording system. Then wave summation or superposition. So while applying the two successive stimuli, if the second stimulus falls during the relaxation period of the first teach and two curves are obtained. So second stimulus that is applied or falls during the relaxation period of the first curve. Then the first curve that is superimposed by the second curve, and that is known as superimposition or incomplete summation or wave summation. Here also the second curve. Here second curve is bigger than the first curve, and that is also due to beneficial effect. Then summation. If the second stimulus is applied during the contraction period, means here during the contraction period or during the second half of the latent period, the two contractions are summed up and single curve is obtained, and that is known as summation curve or complete summation curve. Both the curves are summed up and we obtain only one curve. Okay, and that is known as summation curve or complete summation curve. Now summation curve that look like a simple muscle twitch, but it is different from it because the amplitude of this summation curve is greater than that of the simple muscle curve, and this is due to summation of the two contractions to give rise to one single curve. And another difference is that the base of the summation curve. So this one base of this summation curve is broader than that of the simple muscle curve. So there are a main two differences. The amplitude of the summation curve is greater than that of the simple muscle curve, and also the base of the summation curve is also broader than that of the simple muscle curve. Then effect of multiple stimuli. So in a muscle nerve preparation, the multiple stimuli that causes two types of the effect depending upon the frequency of the stimuli, and that is fatigue and tetanus. So first of all, what is the fatigue? Fatigue is defined as decrease in the muscular activity due to repeated stimuli. When we apply the stimuli repeatedly, after some time, the muscle does not show any response to the stimulus, and that condition is known as fatigue. So this one is a fatigue curve. So when the effect of repeated stimuli is recorded continuously, the amplitude of the first two or three contraction increases. So here you can see this is the first curve, second curve and third curve. Okay. So the amplitude of this curve are increases and then declines. Okay. Then gradually declines, and it is due to beneficial effect. Afterward, the force of the contraction decreases gradually, and it is shown by the gradual decrease in the amplitude of the curves. All the periods are gradually prolonged. So which period? Latent period, contraction period and relaxation period. All the periods are gradually prolonged. Just before fatigue occurs, the muscle does not relax completely. Okay. Just before the fatigue occurs, the muscle does not relax completely, but it remains in a partially contracted state. And this state is known as contracture or contraction remainder. So here you can see the muscles does not completely relax, but it remains partially in a contracted state, and that condition or state is known as contracture. Then why the fatigue set up in the muscles? What are the causes of fatigue? So exhaustion of the acetylcholine in the motor end plate, accumulation of the metabolites like lactic acid and phosphoric acid, then lack of nutrients like the glycogen and lack of oxygen. Then seat of fatigue or site of fatigue. In the muscle nerve preparation of frog in animal experiments, so neuromuscular junction, that is the first seat of fatigue, and it is proved by the direct stimulation of the fatigue muscle. If the muscle is fatigued and if we give a direct stimuli to the muscle, then that cannot be stimulated. So fatigue muscle gives response if stimulated directly. However, the force of the contraction is very less and the contraction is very slow. And second seat of the fatigue is muscle and now cannot be fatigue. In intact body, the site of the fatigue are in the following order. So beds or pyramidal cells in the cerebral cortex, then anterior grey horn cells or motor neurons of the spinal cord, then neuromuscular junction and muscle. Then recovery of the muscle after fatigue. Fatigue is a reversible phenomena and fatigue muscle that recovers if given rest and nutrition. For this, the muscle is washed with saline. So in this figure, you can see if we give a direct stimuli to the muscle, then this response is obtained. And after the fatigue, if we can give or wash that muscle with saline, then recovery curve is obtained. Then what are the causes of recovery? So removal of metabolites, formation of the acetylcholine at the neuromuscular junction, re-establishment of the normal polarized state of muscle, availability of nutrients and availability of oxygen. Now recovered muscle differs from the fresh resting muscle by having a acid reaction and the fresh resting muscle is alkaline. But the muscle that recovered from the fatigue, that is a acidic and so it relaxes very slowly. In the intact body, all the processes involved in the recovery are achieved by the circulation itself. In human beings, the fatigue is recorded by using an instrument that is known as Mozos ergograph. Then tetanus. So what is the tetanus? That is defined as a sustained contraction of the muscle due to repeated stimuli but with high frequency. When the multiple stimuli are applied at a higher frequency in such a way that the successive stimuli fall during the contraction period of the previous twitch, so the muscle remains in the state of tetanus. It relaxes only after the stoppage of the stimulus or when the muscle is fatigued. So when we give the stimulus, when the multiple stimuli are applied at a higher frequency in such a way that the successive stimuli fall during the contraction period of previous twitch and the muscle remains in the state of tetanus and it relaxes only after the stoppage of the stimulus or when the muscle is get fatigued. Then tetanus and genesis of tetanus curve. Genesis of the tetanus and tetanus in frog's muscle is recorded by using the instrument known as vibrating interrupter. It is used to adjust the frequency of the stimuli as 5, 10, 15, 20, 25, 30 and 35 per second. While increasing the frequency, the fusion of the contraction increases every time. And finally, the complete tetanus occurs. Nowadays, the electronic stimulator is also used. By using this instrument, the stimuli with the different strength and frequency are obtained. So, this is a graph of tetanus and that is a graph of clonus. Clonus means incomplete tetanus and frequency of stimuli increases gradually. When the frequency of the stimuli is not sufficient to cause the tetanus, the fusion of the contraction is not complete and it is known as incomplete tetanus. So you can see here there is a not complete fusion of the contraction. So that is known as clonus. Here some periods, contraction periods and relaxation periods are also occurs. So there is a no fusion of the contraction is not complete. So that is a incomplete tetanus and that is a complete tetanus. Here you can see the totally fusion of the contraction. Then frequency of the stimuli necessary to cause the tetanus and clonus. In the frog's gastrocnemius cytic nerve preparation, the frequency of the stimuli required to cause the tetanus is 40 per second, and for clonus it is about 35 per second. In gastrocnemius muscle of the human being, the frequency required to cause the tetanus, that is about 60 per second, and for clonus the frequency of the stimuli necessary is 55 per second. So this is a graph for the genesis of the tetanus and tetanus curve. Then pathological tetanus. Sustained contraction of the muscle due to repeated stimuli of the high frequency, that is known as physiological tetanus. But it is distinct from the pathological tetanus, which refers to the spastic contraction of the different muscle groups in the pathological condition. And this disease is caused by Bacillus clostridium tetani, that is found in the soil, dust and manure. The bacillus enters the body through a cut, wound or puncture caused by the objects like the metal pieces, metal nails, pin and wood splinters. This disease affects the nervous system and its common features are muscle spasm and paralysis. The first appearing symptom is the spasm of the jaw muscles resulting in locking of the jaw. Therefore, the tetanus is known as lockjaw disease. The manifestations of the tetanus are due to a toxin secreted by the bacteria. If the timely treatment is not provided, the condition becomes serious and it may even lead to death. Now, what is the Treppe or staircase phenomena? Treppe or staircase phenomena is the gradual increase in the force of contraction of the muscle when it is stimulated repeatedly but with a maximal strength at low frequency, and it is due to beneficial effect. Treppe, that is distinct from the summation of the contraction and tetanus. Then effect of the variation in temperature. If the temperature of the muscle is altered, the force of the contraction is also affected by warm temperature. At warm temperature of about 40 degrees centigrade, the force of the contraction increases and all the periods are shortened because of the reason like excitability of the muscle increases, chemical process involved in the muscular contraction are also increased, and viscosity of the muscle decreases. So this is a graphical recording of effect of temperature. So this is a 40 degree centigrade. So you can see all the periods of the simple muscle twitch are decreased like latent period, contraction period and relaxation period. Now cold temperature. At a cold temperature of about 10 degrees centigrade, the force of the contraction decreases and all the periods are prolonged because of the reason like excitability of the muscle decreases, chemical process are slowed or delayed, viscosity of the muscle increases. Then what is the heat rigor? At high temperature above the 60 degrees centigrade, the muscle develops a heat rigor. Rigor means to shortening and stiffening of the muscle fibers. Heat rigor is the rigor that occurs due to increased temperature, and it is irreversible phenomena, and it is due to coagulation of the muscle proteins like actin and myosin. Then other types of the rigor are cold rigor, calcium rigor and rigor mortis. So due to exposure to severe cold, and it is reversible phenomena, that is cold rigor. Then calcium rigor, that is due to increased calcium content and it is also reversible. Then rigor mortis, that is develops into the muscle and develops after the death. So we will discuss in the rigor mortis in my next lecture. Thank you.